Hello everyone, hope you're all doing good. So friends, in today's video, let's learn how to solve quadratic equations which have imaginary roots. This is a request from one of our viewers. So friends, in earlier classes, we have learned what are quadratic equations. Yes, they are equations which have degree 2 and this is the general form ax square plus bx plus c equals to 0. We have also learned that whenever an equation has degree 2, that means it can have two roots, right? And we have also studied what are the nature of these roots in previous classes. So we'll just do a quick recap. So to find the nature of the roots, we always used to find the discriminant or the d, which is nothing but b square minus 4ac, right? And with that value, we used to think of what are the possibilities. Suppose the discriminant was greater than 0, then we would say that yes, the roots of the equation are real and distinct. Distinct means different. So we used to get two different roots, but they are real numbers. When d was equal to 0, we would say that the roots are real numbers, but they would be the same. They would be equal, right? But if d was not greater than 0, it was not equal to 0, that means it has to be less than 0. In that case, we used to say that the roots are not real, they are imaginary, and we used to stop the question there. We would never find out what are the actual roots. But friends, in today's video, we are now going to proceed and see how exactly to find the imaginary roots of a quadratic equation. So for that, let's take a few examples. So here I have this quadratic equation, x square plus 36 equal to 0. So friends, let's see how to solve this. Now I can bring the 36 to the other side, so I'll get x square equal to minus 36. Now we all know that whenever we square a real number, we will always get a positive answer, is it not? When we suppose square 6, we will get 36. Even if we square minus 6, we will get 36. But here we are squaring a number but still getting a negative answer. That means definitely x is not real, friends. See, that's how we come to know that yes, this is a quadratic equation, but x does not have any real roots, right? So how do we proceed? Well, what we can do is we can take square root on both the sides. So we'll get plus or minus square root of minus 36. Now in the earlier classes, we used to just stop at this step, remember. So now we are saying that x equal to plus or minus square root of minus 36. Now we have all learned about complex numbers, I'm sure. What are complex numbers? Yes, square root of minus 1, we call it as iota. Yes, iota or imaginary number. So what we are going to say is plus or minus square root of minus 36. We are cleverly going to write it as square root of minus 1 into square root of 36. And now, yes, you have guessed it. I will write square root of minus 1 as I, square root of 36. What is it? Yes, it is 6. So friends, the roots of this quadratic equation are 6i plus 6i and minus 6i. That's it. These are two roots. Definitely they are not real, they are imaginary, but these are the two roots. Did you observe, friends, that they are just the conjugates of each other? Conjugates means just the sign is different. The number is the same, but the sign is different. So for such type of quadratic equations, it's very easy to find the imaginary roots. Now friends, here is the next quadratic equation. X square plus 2x plus 4 equals to 0. Now, just by looking at this quadratic equation, we really can't say whether the roots are going to be real or imaginary. In this example, it was very clear that the roots are not real. Well, here we can't say with that much guarantee. So what we will do is we'll find the discriminant, which is nothing but b square minus 4ac. Now what is b over here? Can you tell me? Yes, b is 2, a is 1, right? And c is going to be 4. So let me quickly find the discriminant. It is 2 square minus 4 into 1 into 4. So 2 square is 4 minus this is 16. 4 minus 16 minus 12. So yes, definitely it's less than 0. That means the roots are going to be imaginary. So So whenever you have such type of quadratic equations, just make sure that the roots are real or imaginary. Now, how do we find the roots in this case? Well, we are going to use a method known as completing the square method. What is it? Completing the square method. So friends, in this method, we will use the algebraic identities. I'm sure you have learned this in the previous class. Do you recall these? Yes, x square plus y square plus 2x square and x minus y the whole square. What is going to be the difference? This was plus 2xy. This is minus 2xy. Now, what are we going to do? Let's compare this equation. Okay, this is our quadratic equation. Now, which identity is similar to this part of the equation, x square plus 2x? Now, there is a x square in both the identities, but here you have plus 2xy, here you have minus 2xy, and here I have plus 2x. So, which identity is similar? I can say this identity is similar, friends, okay? So, x square plus 2xy plus y square. If I somehow write this part of the equation in this form, then I can use the identity. Okay, you'll see how that will help us later. Okay, now x square and x square are going to be the same. Now I'm going to equate 2x with 2xy. Now why am I doing this? So that I'll know what is the value of y. Yes, y is going to be 1. That means what is going to be y square? Again 1 in this case. So if I somehow bring a 1 here, then I can substitute this identity. Is it clear, friends? Okay, so let me just bring the 1 over here. I'll write x square plus 2x. Remember, I'm just writing this equation. I will just write a 1 here, friends. But of course, you know that I cannot change the equation. I cannot just add a 1. If I've added a 1, I also have to subtract a 1 immediately. And then I will write the plus 4 equal to 0. Till here, I hope this is all clear. Now look at the magic happening. X square plus 2x plus 1 is of the type this identity. See, x plus y the whole square, where y is going to be 1. That's great. So now instead of this whole thing, I'm going to write x plus 1 the whole square minus 1 plus 4. What is minus 1 plus 4? Plus 3 equals to 0. Till here, just look at the progress we have made. From here, we have come to this point. Now, these two look very similar. Did you see? Yes. Now, I'm going to follow the same method that I did over here. I'll bring the 3 to the other side. So, I'll just do it over here, friends. So, I'll do x plus 1 the whole square. I'll bring the 3 to the other side. So, now what can I do? I can take square root on both the sides. So, I'll get x plus 1 equals to, because I'm taking a square root, it will be plus or minus square root of minus 3. But again, what is square root of minus 3? Yes, it is I root 3, and that is x plus 1. That means x is equal to minus 1 plus or minus I root 3. Just look at the very easy way in which how we have got the two roots. Again, did you notice these are two complex roots, complex numbers, and they are also conjugates of each other. Just see the sign is different. So this is the method. Now here is the third example. This is again a quadratic equation. We cannot say just by looking at it if it is real or imaginary, the roots. So let's find out the discriminant. It is b square minus 4ac. So b is 9. A is 21 and C is 1. So B square is going to be 81 minus 4 into 21 into 2. Okay, friends. So I'll get 81 minus, I'm sorry, this is not 2, this is 1. So I'll get 84 over here. So 81 minus 84 is minus 3, which is again less than 0. So we can say that the roots are imaginary. But the problem here is, friends, we can't use completing the square method over here. Did you look at the coefficients? They are really big, so it will be very difficult to use that method. Hence, we will be using the formula method. What is the formula method? I'm sure you know that. Minus b plus or minus square root of b square minus 4ac divided by 2a. So in such cases where you have very big coefficients, just go for the formula method. So what is minus b? Yes, it is going to be minus 9 plus or minus. Now this whole thing I've already found out. Yes, it is nothing but the discriminant, which is minus 3. So I'll just put minus 3. 2 into a is going to be 9 over, sorry, not 9. It's going to be 21 over here. So I'll get minus 9 plus or minus. What is square root of minus 3? Yes, I root 3 divided by, this is going to be 42, right? That's it, friends. This is the value of x. So if you want, you can little bit simplify and write it like this also. So these are again the imaginary roots of the equation. Again, they are occurring in conjugates. So friends, for practice, do solve these two quadratic equations. Let me know what are your answers in the comment section below. And if you found this video useful, do like and share. Consider subscribing to Enjoy Math. And please do leave your comments, your questions, your feedback in the comment section below. So till we meet